Hi everyone and welcome to the second part of Chapter 8. In this part, we will learn to program AHT20 sensor for humidity and temperature measurement. The AHT sensor is a powerful component that provides accurate measurements for both humidity and temperature. Imagine having the ability to monitor and respond to changes in your project's environment. Whether it's a home automation system, a weather station, or a smart gardening project. When we run the code for this activity, it prints the temperature in Celsius and the relative humidity percentage in the shell console. Temperature and humidity rise slowly when finger is in contact with the AHT20 sensor. To start, we need first to enable the plotter function in Thony IDE to have a better visual on the sensor value. Now we are ready to write the code for this activity. Line 2 provides support for the AHT20 temperature and humidity sensor. Line 5 initialize I2C communication with the AHT20 sensor. Line 8 reads the temperature data from the AHT sensor and stores it in the temperature variable. Line 9 reads the relative humidity data from the AHT sensor and stores it in the humidity variable. Line 10. This line prints the temperature and humidity values in the formatted string. The 2F inside the F string is used to format the floating point numbers to 2 decimal places. Notice here, printing both temperature and humidity in the same line of code will allow the plotter to plot both values in the same graph. Understanding the environment is crucial in many electronic projects. The AHT20 sensor allows you to gather real-time data on humidity and temperature, enabling you to make informed decisions in your coding and design processes. However, to achieve an accurate measurement, we must understand how the sensor module consistently enables good ventilation to prevent the sensor from being affected by the heat radiated from the components nearby. The melt slits or white lines around the sensor decreases thermal conduction through the printed circuit board. This is because the slits act as a thermal barrier, reducing the amount of heat that can be conducted through the PCB. When the measurement frequency is too high, the temperature of the sensor module will heat up, which may affect the measurement accuracy. To keep the temperature from rising, it's recommended to include a 2-second interval for the data collection cycle. Well done completing part 2 of Chapter 8. In the next video, we will build a climate control greenhouse. Thanks for watching and I will see you in the next video.